So I welcome you all on this webinar on basics of Lean Six Sigma and the role of yellow belt in effective implementation of it. So this is the 1 hour training, 1 hour webinar in which we will be covering many topics. So I hope this precious time of years and hours will be some fruitful for us. Okay, so let's start for our webinar. So these are some of the points that we will cover today. First of all, the introduction of the Lean and Six Sigma. We will look at the term Six Sigma and why we only call it a Six. Okay. Then the Six Sigma approach, the Lean approach, and what are the different steps and what are the two methodologies that we follow, that is DMAIC and DMADV or DFSS. So we will look at these. Then one very important thing that we will cover today, that is the 7 quality tools, the importance and basics of it. So this is very, very essential to solve many of the problems, the practical problems. Then we will go to the implementation roles in Six Sigma. So there are multiple belts, as you can see, from yellow to black belts. So we will look about who are these people, who are these black belt holders or different belt holders, what is the prerequisite to be such a person, what are the responsibilities come with that, what is the future scope, and how to get a practical hands-on experience in it. So we will look at all these points in detail. Then we will also see what are the importance of Six Sigma certification in a professional and a personal life as well. And the last point is how to go ahead to be an expert in this Lean and Six Sigma. So I welcome you all, and in this 1 hour we will try to clear all these topics. So before going to that, I'll just introduce ourselves. We are a team of having over a decade of experience in this process engineering, Lean and Six Sigma, TPM, and also innovative engineering solutions provider. So we have been working in this sector for a long time, and our mission is to delight our customers beyond their satisfaction and to change their lives positively. So this is our mission, and in that we are working constantly. So to the change lives of our customers and whoever students and associates are. So this is our website for your reference. You can go there and have more details about us. These are our trusted leading brands whom with we are associated, Whirlpool, Crompton. So these are the few of our customers. So before wasting much time, just important thing that this is COVID time, as we know that. Please wear a mask so that we can save, and also let us may all use this time to better ourselves. We know that this is a tough year, but let's use this time for such fruitful activities like reading, exercising, and working on our personal as well as professional life. So let us start with our webinar's core topic. So whenever we see that we have to improve some projects, we have to improve some process. So how to improve, right? So that is very, very essential questions that we should ask. There are multiple dimensions to it. Which approach to follow for any improvement activity? Who will have which responsibility? And let's say we are taking some project, but how to ensure the success of it? And whenever we start, so when to stop it and when to initiate it again? And how much improvement is really required? So how much improvement is really an improvement? So these are some of the questions that traditionally we have been facing for any improvement activity. And the promising solution for this is Lean and Six Sigma, Lean Six Sigma. So we will see about this, why this Lean Six Sigma approach is very essential, and it is currently very useful all over the world for all these whatever questions we have seen, because it contains very two unique features for Lean Six Sigma. First is a systematic methodology. It is having DMAIC approach. We will see about it in detail. What is the DMAIC approach of problem solving? So that provides us very promising bedrock on which we can have our improvement activities. And also it contains a wide range of toolkits, so which we can use and with which we can improve our process, we can monitor it, we can also keep on track on that, and that ensures the long-term success of these improvement activities. And the second key feature of the Lean Six Sigma is the belt system for skills and responsibility management. So this is also a very essential thing when it comes to the shared responsibility or the improvement of the skills. So there are multiple belt system in Six Sigma. So there is a management of training and skills enhancement, and also it ensures that a learning process and there is a systematic plan to go for all these levels. So due to this, the Lean Six Sigma approach is very helpful. We will look at this. So let's say, first of all, we will look at the Six Sigma, the origin of Six Sigma. Actually, the company that invented Six Sigma is Motorola. Motorola started Six Sigma approach to achieve one of the top 10 corporate goals of improving quality by 10 times within 5 years in 1981. So it started in 1970s, 1980s decade. The term Six Sigma was coined by Bill Smith, who was an engineer with Motorola. So the Bill Smith is very important in this genesis of this Six Sigma term. Late in 1970s, what happened? The Motorola started experimenting with multiple problem-solving methods like statistical analysis. And in 1987, with all their trials and with all their efforts, they came up with a program called as a Six Sigma program. And it was officially launching in 1987. And what are the benefits from these activity? So there was a significant increase in their bottom line of the functioning, and in fact they also have documented that the more than 16 billion savings, and at that too in the decade of 1980s. So this is the potential that Six Sigma can offer to us. So after the genesis at the Motorola, the next part is how it got perfected and how it got the form that we see today as a Six Sigma. So there is a role for General Electric in that. Jack Welch launched this program in GE in the January 1996, and with that they were completely focusing all their business activities, all the company on this Six Sigma approach. In 1998-99, the Green Belt exam certification became the criteria for management promotions, and in the year up to 2002-03, it was also for the criteria for promotion to management roles. And in this way, the Six Sigma approach, Six Sigma methodology got ingrained into this General Electric. And due to them, the scope of the Six Sigma initiative has changed from manufacturing to the entire business, like service, product design, and innovation. So now Six Sigma can be used in, let us say, its manufacturing, production, its services like banking, financial, or BPO. So multiple sectors are there which are now using this Six Sigma. This is the statement from Jack Welch, who was the chairman of GE and who put forth this agenda for GE. So he says that Six Sigma has forever changed GE. Everyone, from the Six Sigma zealots emerging from their black belt tours, to the engineers, the auditors, and the scientists, to the senior leadership that will take this company into the new millennium, is a true believer in Six Sigma, the way this company now works. So this is kind of confidence that they have in this Six Sigma approach. We will just quickly look through the history of these improvement activities or the quality systems in what happened during this last decade. So first started with Eli Whitney's interchangeable parts. Okay, so these are the multiple stages, and there were multiple opportunities, multiple difficulties in the last decade, that the last century or previous from that also. So there were multiple difficulties for them, and they achieved somewhat tools, some different methodology, some different solution for that problem. The interchangeable parts was one of the solution for mass production. Then go no go gauges. So this was the next stage. Then Henry Ford assembly line. So this was a revolutionary thing. So there was the first time the assembly line was there. So, and after the World War II as well. Okay, so there were multiple challenges, like there were resource scarcity, and due to that, the work of Deming in Japan, Juran, and the work of Juran in Japan. So these kind of opportunities emerged, this kind of tools, methodologies were emerged. There are multiple tools which were emerged during this all span of time, up to this Motorola in 1987 launching the Six Sigma. So actually, this Six Sigma approach, when we see, so actually this is not a something new approach that was invented in 1987 or let's say in 1980s century, 1980s decade. It was the accumulation of all these successful tools, all these successful methodologies which were able to have some solution on different problems. And what the Six Sigma approach did was, it was the culmination of all these tools, effective use of all this methodology, and it was, we can say, a toolkit for all these multiple tools from different time, from different locations, and the effective utilization of that. So on that note, we will go forward. These are some of the companies, some of the great believers in Six Sigma. As you can see, Allied Signal, that is now merged into the Honeywell, then GM, Cummins, General Electric, as we have seen, DuPont, Ford, Wipro, and HDFC Bank. So if you look at these companies, so there are multiple, like this is a banking, HDFC, this is motors, this is automobiles, this is chemicals, this is the IT company. So there is not a single, currently the Six Sigma is being useful in multiple strata of companies. And there is not, let's say, only a company that is using a Six Sigma, only manufacturing or any production. Because if we see the quality, which is the key criteria, which is the key point where all these companies operate, because every company has to offer the quality. And when we say quality, what is the meaning of quality is the uniformity around the target value. So every company has a customer base, and their customer expects some target, some expected output from them for which they are paying. And the Six Sigma approach is used to get this quality. Now we will see one demonstration. Let's say this is about the quality of airlines. Okay, so let us assume that this is the airlines company, this is the aeroplane, and it is landing on a runway. Okay, the pilot is landing this plane every time on this runway. So from this red line up to this red line, this is a runway. Sorry, just a minute. Yeah. So from here to here, this is the runway, and this central white line is a target. So and apart from this runway, there is a danger. Okay, so apart from this red line, this is danger. But whenever this is a specification line, but pilot is landing within the specification line every time. You can see these dots. Every time pilot is able to land into this line, and the plane landing is perfect, because as we can see, this is specification line. So all our readings are within the specification line. So all specifications are met, and therefore we can say this is a quality. Now we will see the second scenario. Just a minute. Yeah. So we will see now second scenario. All right. So this is aeroplane second time, and now this pilot is able to land every time on this central white line. Okay, every time is landing on this central, closer to the center. on the runway. Okay, so these are the two cases of the pilots. Both the time quality is good, we can say there is uniformity, and the customer specifications are met. As we have seen, this is the specification, and both the times specifications are met. So at this point of time, I would like to ask you, with which pilot you would rather fly? Which you will choose, this first or the second one? Would you like to answer, anyone?
Like the second one.
Right. Okay. Thank you, Mayur. So Mayur is saying he will fly with second one. So any other answer? Okay. So one for pilot 2. Any other answer? All others are going. Okay, right. Okay. Thank you, Merrick. So you are also opting for second one. Okay, right. So we will move ahead. Your right. So we will fly with the second pilot. Now we will see. The reason is there is less variance, right? The variability in this is very less. Variability is very more. So there are some chances that the landing may go beyond this specification. It may go beyond this. But when it is closer to the center, there is, we can say there is assurance that we will get quality every time right. But if we are seeing this, only these two images, this is pairs and this is somewhat hugging to this central line. But producing to the target value means we need to change our habits. It is not a so easy task. It is not so easy to change this habit from this operation to this operation. So it needs multiple improvement into activities. It's required to change our habits. And this is the same case with our, let's say, a manufacturer. So his customer is also expected the same case. This is the specification for them as well. And if the manufacturer, or in this case the aeroplane industry, so the both cases we can compare with each other, and we can understand that the customer, like as we have chosen this pilot too, so anyone will choose this second customer, which is having the less variance and who is providing the quality products. So at this point, we will see some three main definitions here. The customer. Okay. So the customer is anyone who receives product, service, or information. And that's why it is important to note here that it is not only product, it is also service and information. That's why it is not as if the Six Sigma is only applicable to the manufacturing industry, as well as any customer who receives service and information. And that's why there are multiple sectors in which the Six Sigma can be applied. Second is the opportunity. It is the every chance to do something either right or wrong. That is the opportunity. And third is either that opportunity leads to the success or the failure. And the success and failure in terms of customer specifications. It is not in terms of producer. So when we say that it is a success, so that means that the quality of that product is superior, the customers are happy, and they are accepting our product. And if our product fails at any of the customer criteria, so that means it's a defect or it's a failure. So with this concepts in mind, we have started our session with Lean Six Sigma, right? So we will first look, now we will look at this Lean. So what is this Lean? These are two completely different parts, two different things that can be implemented into an industry. So first part is, what is Lean? Lean is the elimination of anything not absolutely required to deliver a quality product or service on time to our customers. So as we have seen, what is a customer, what is our defect or opportunities. So we have multiple these opportunities when we serve our customer. So at that point of time, lean attempts us to eliminate anything that is absolutely not required. Means customer is not asking for it, but though out of habit, out of a different kind of waste, we are producing that. To reduce that waste and to keep the only provide value to the customer. So that approach is called as a lean. So in this diagram also, as you can see, if we want to go from point A to point B, so this is some kind of path we follow generally when we are not applying such lean concepts. With the application of lean, we will go straight from A to B. The waste along the path will be completely eliminated. So as we have seen the losses, so there are three major losses. They are called 3 M's. These are the Japanese concepts: Muda, Mura, and Muri. Okay, as this image will tell us. Okay, so Muda is a waste. You can see in this image, this person is pouring water into this bucket, which is already having holes. So whatever amount of water he will pour in this bucket, the bucket will not get filled. That is completely wastage. These are the waste occurring in the process. This is a Muda, the waste. Second is Mura. In English, we can say unevenness. If we can see here, one bucket is very small, very, let's say only 2 liters or 3 liters, very small, and other is very big bucket, 15 liters. So what is happening? He is not able to balance. There is not even weight on his shoulders. So that is the unevenness. And the third is the overburden. Let's say this person Muri, this third M is Muri. So let's say this person is carrying more water than his capacity is. He is overburdened, and that also leads to the losses in the coming time. Other very beautiful example is about this truck loading. Okay, so you can see, let's assume that the truck's capacity is 3 tons. So it can carry 3 tons very easily. If the overburden, here we have seen Muri, the last one. Okay, so if the truck capacity is 3 and we are loading with 6 tons, then that is the Muri, that is overburden, that is a loss. Okay, second, Mura, that is the unevenness. So on one truck we are loading 4 tons, capacity is 3, and second is only 2 tons we are loading. So that is also the underutilization of this and the overutilization of that. That is the unevenness over there. And the Muda, what we can say, the 2 tons are loaded on each truck, the 3 trucks are used, and this is some kind of waste or Muda, as we say. And the ideal case, as we have seen, the 3 tons, that is the ideal weight for that truck, and that should be loaded. So with this in mind, with this 3 M's, we will look at what are the kinds of waste that are occurring in the industry. There are 8 waste, we call them, and they are very famous for any industry. If they want to reduce waste, so they should start asking questions about these 8 waste. So first is a defect. So as we have seen, any effort caused by the rework, scrap, or incorrect information, so that is a defect. Defect means that is not adding any value to the customer specification. So these are just, we have to rework, we have to invest our time, our money, our resources. Second is overproduction, means we are producing more than that is the needed. Third is waiting. So the waiting time, the machine is waiting or the operators are waiting. So that kind of waiting time is in the queue to get operated, to get processed in our firm. Next is a non-utilized talent. So many times not using people's talent or skills or knowledge, which is their capability. So that is also one type of waste. Next is transportation. If there is unnecessary movement of products and materials, so that leads to this kind of waste. The inventory, the excess of products or materials. So if we are storing them, so that is also one kind of waste. And then motion. the unnecessary movement of people, like the walking movement, or the layout of the factory, layout of the firm is not correct. So due to that, the motion waste is there. And the last is extra processing. So this is the unnecessary processing of activities in the process, in the our product, in our process, and that is not actually adding value to our customer. So we have to identify waste in this 8 kind of waste. So there is some kind of waste present in our organization. So we have to track that and we have to eliminate that, and that we will call as a lean. So after doing, analyzing these waste and removing this, so what are the benefits of lean that we can get? First is a reduced inventory. We will get rid of the excess inventory, and as we know, the inventory is the blockage of money. Okay, so that money which is going to block, so that gets released, and that again lead to multiple benefits that we are seeing in ahead, like increased productivity, then reduce lead time, as we have reduced the excess motion, excess transportation. So that kind of things reduce the time required for the process or our product. Then that also leads to improve on-time delivery. The sales are also improved, increased. Then there is improvement in quality, and overall the capacity of the plant, the capacity of the organization is increased. So these are the benefits that we get from lean. Next, the second part of the term, as we have seen, Lean Six Sigma. So this is the second part, Six Sigma. So what is Six Sigma? So it is a focused approach used to reduce variation in any kind of process, including manufacturing, pharmaceuticals, healthcare, accounting and finance, BPOs, and many more. Almost every sector of operations. As we have seen, the customer, that kind of whoever get product, service, information. So this kind of, there is multiple sectors operating in our industrialized world. So there we can apply this Six Sigma. And as in the starting slide, there we have mentioned this approach, the systematic approach, right? So this is the define, measure, analyze, improve, and control. So this is the 5-phase approach, 5-part approach that we are going to use in this Six Sigma. So there are a few examples, like we can say the DMAIC project. DMAIC stands for these 5 approach, these 5 steps: define, measure, analyze, improve, and control. So to improve customer satisfaction by reducing complaints. So it strives to improve the customer satisfaction, and what we do with that is also plan and execute organizational strategic goals. So whatever the strategic goal of organization is, so we apply the Six Sigma approach to achieve that strategic goal, and with that the success for the organization. Then essential part is the reduce operational as well as the overall cost. As the cost decreases, the bottom line that increases, means the profit for the company also increases, and also it also reduces and eliminates the defects in process and thereby in products. So whenever we are operating to reduce the variation, so we are also improving the quality of the products, and we are also improving improve where there is inefficiency in our processes. So why the term, there is Six Sigma term, right? So we will see first the Sigma. Sigma is a Greek letter used to describe variability in that process. It is called as standard deviation in statistical terms. So we have been studying the Sigma in our school level as well. So what is it? So actually it's a Greek letter, and statistically its meaning is standard deviation. So the standard deviation is a measure of how far the observations in a sample deviate from the mean. So for that we will see one example. Let's say this is one example where we have plotted metabolic rate, and there are two sectors. One is we have taken one female and second is male. So against that we have plotted the metabolic rate. So if you can see the metabolic rate for female, so that is, let's say, from around 800 to 2000, like the spread lowest and highest value. You can see the spread of this how far the observations are placed in that. And the second case, we can see how far these are placed. So in a simple term, when we say the standard deviation, by simply looking at the standard deviation value of these two, you can say that this is more, there is more variation in this second category. So this is the way how we can say there is a standard deviation. Now the meaning of it in the statistical term, so we will look ahead. The statistical representation of Six Sigma describes quantitatively how a process is performing. So with the value of that sigma, we will get how our process is overall operating. And to achieve a Six Sigma, whenever we say we have achieved Six Sigma or this company is operating on Six Sigma, so what does that mean? So that means that the process must not produce more than 3.4 defects per million opportunities. So for the time being, you can also call this as a ppm, parts per million defects. These are some slight variation in that, but for simplicity, we can say there are 3.4 defects in 1 million or 10 lakh products or 10 lakh opportunities, 10 lakh transactions, we can say. So to feel this statistically with diagrammatic representation, we will now look at that. So let's say these two red lines, these are the customer specifications, and whenever we go beyond that, that is defective. Okay, so anything between this customer specification lower value and upper value, we will say that customer will accept this product or process or transaction. So this is the first process. This is the distribution curve, you can see normally distributed. And if you see the process variation, how the output we are getting from that process, so we have plotted it against this customer specification. And now we will look at the sigma level DPMO, that is defects per million opportunities, and percentage yield, means what percentage of products are coming as good or acceptable to customer, means within this red line. Okay, so for, let's say, for 1 sigma level, whenever we talk 1 sigma, so there are how many defects DPMO? So there will be 6,91,462 defects will be there for 1 million opportunities, means for 10 lakhs there is almost 7 lakh defects are there. And you can see the corresponding is 30% of yield, means around 30% we are getting products as right. Most of the products will go beyond this customer specification. So if we are improving from 1 sigma to 2 sigma, let's see what happens. So this, we have improved this process. Now we have reached to 2 sigma level, and now the DPMO level, the defects level, has come to around 3 lakhs, and now we are getting around 69% yield, means good parts. 69% parts are falling within this customer specifications. Now let's go ahead with 3 sigma. With 3 sigma, we are having DPMO level, we have reduced up to 66,000, and now yield is around 93%. So in this way, when we keep reducing the spread of this distribution plot, distribution curve, so we are ensuring that all of our readings, you can see over their yield, all of our products should fall within this customer specification. So what will happen when we go to 6 sigma? So this is the criteria for 6 sigma. When we say 6 sigma, as we have seen, 3.4 defects. So up to the 6 sigma level, we should have only 3.4 defects per million opportunities, and that will give us yield of 99.9997%. So this much accuracy, this much precision we are having while producing this product. And this is, as you can see, the spread, this is well within the customer specification. Okay, so we can say that 99.999, 3 times 9 and 7% of the products are good parts, and they are fulfilling the customer specification. So by looking at Lean as a differently and Six Sigma as a differently, both giving some benefits to us, let us see when we combine these two, Lean and Six Sigma, so what kind of benefits we can get. First was, let's recapitulate what we have seen, the benefits part of this two. Hello, is there any question? Okay, so if we see the Lean, so Lean's focus on reducing waste in the process. Okay, so wherever there is a waste, so that should be reduced. So that was the focus of Lean. And the Six Sigma approach was defect reduction, right? The spread we have seen, the defects level to 3.4 DPMO. Second was cost reduction due to WIP, work in progress, and resource reduction. So we are reducing the inventory, we are reducing the waste in this Lean approach. So that was our focus. And in the Six Sigma, there is cost reduction due to defect reduction, because we have directly targeted to the defects. Then the third, we can say, the Lean, as we have seen, it is about motion, it is about transportation. So that was between the processes. Okay, so between process A and process B, so the Lean will operate between that. So whatever waste there are, that will be removed with the Lean. And the Six Sigma focuses in the process. So what is the defect level of that process? So Six Sigma works on that process level. And with the Lean, we have seen the speed of the process, speed of overall operation increases. And with the Six Sigma, the quality as output we get. So quality improves. So whenever we combine this Lean and Six Sigma, so with the speed and quality, we will get at the lowest cost. And that is the true benefit when we apply this Lean Six Sigma together. So one is a question that why Six Sigma, not 5, 7, or 8, right? So if we are seeing that achieving Six Sigma, so that level of accuracy itself is a very difficult, and lots of systematic approach is required apart from capital investment. So it is not as easy task to go for Six Sigma to achieve that level. There is a lot of systematic approach, systematic efforts are required. Also, capital investment is also required to achieve that kind of defect level, or that kind of precision in our processes. But if you want to improve the process further to 7 or 8 Sigma level, it increases the cost of process drastically to achieve the little more accuracy. The smallest, the very minute improvement is also required a lot of money for that. And if we see most of our companies, so where they are actually, they run over 3 to 4 Sigma levels, because that is the kind of operation currently going on in most of the industries, most of the traditional companies, we can say. And a process which is running in 5 Sigma levels could be improved to 6 Sigma levels by following some systematic approach and little more investment. So from 3 to 4 Sigma to 5 Sigma and 5 to 6 Sigma, so that can be done. But in some sectors like aeroplane, or we can say healthcare, so these are some of the industries where we require more than 7 Sigma, more than 8 Sigma even, because we cannot say if we are flying 1 million planes, there will be crash of 3.4, or 5 planes will be crashed, 4 planes will be crashed, because that is a huge loss for the lives of people. And due to that, they have to operate beyond the level of 7 Sigma, beyond the level of 8 Sigma, because there is a cost of, there is associated risk of safety, there is associated risk of lives of people. and for that purpose they have to go for higher level. But for a general company, for the most of the companies, the Six Sigma level is good enough. Means that is the good enough level of defects that can be achieved without being too much capital investments. Means it's not astronomically high as going beyond the 7 or 8 sigma, but it is not as low as the current level of 3 or 4 sigma levels. So it also provides, it also gives some challenge as well, and also practically implementable as well. So that's why the Six Sigma level, whenever we talk, we are talking about the Six Sigma level. So let's see now that, let's say we are having one problem. So what is the method of solving that problem, right? So there is a practical problem. In our traditional approach, we analyze the practical problem and we implement the practical solution. This is the common traditional approach. But the Six Sigma approach is somewhat different over here. And what is that? Six Sigma approach is we convert the practical problem to statistical problems. Then by studying the statistical problem, we come to the statistical solution. And from statistical solution, we get to the practical solution. So this is the basic of, we can say, the Six Sigma approach, how it works. So it's like a statistical modeling of the problem, and through which we will get the practical solution. And how we do that? In Six Sigma approach, the practical problem is converted into statistical problem, and this is done by mapping the process, defining key process input variables. Also we call it as KPIVs or X, and key process output variables or KPOVs or Ys. So these are the outputs and these are the inputs, and with the help of that we are mapping all the processes. The power of statistical tools is used to determine a statistical solution, and this is then converted to the practical solution. So this is the way how we operate in the Six Sigma. There are two major methodologies that we use in the Six Sigma, and they are inspired by the Deming's Plan, Do, Check, Act cycle. Okay, this is also called as a Deming cycle or PDCA cycle. So inspired from that, we are having two methodologies. First is DMAIC roadmap or DMAIC methodology. Whenever you want to give superior quality of conformance. So what is it? It is define, measure, analyze, improve and control, DMAIC. And the second approach is whenever you want to provide superior quality of design, that is DMADV roadmap. So that includes, first three are somewhat same: define, measure, analyze, and then design and verify. So whenever you want to design something, whenever you want to give something superior quality at the starting stage, so you will go for DMADV, or also called as a DFSS roadmap. So with this two distinct project methodologies, you can implement the Six Sigma. Let's see in short what this DMAIC approach is. Okay, so first is in define. So what we do, we define our problem, we define what needs to improve, we define the system. And how we do that? So defining the system, then voice of the customer. So what the customer want, what is their specification, what we should provide them, so that is a good service or good product, and defect minimization. So what is that? We have to define first, and we have to also define the project goals in that. Then the second is measure, quantify the problem, measure key aspects, collect relevant data, calculate the as in process capability, means what is the current level of operation that currently our institution, our organization is having. So all that we have to measure in the second phase. Third is analyze. We have to identify the cause of the problem. So we have to analyze the data, we have to draw the cause and effect relationships. We have to go to the root cause or defects. why and why analysis. So such kind of different tools are there with which we analyze the problem. Then it's improve. So we have to implement the solutions and verify that solutions. So in this we optimize the current process. We in this there are multiple tools which we use like DOE, then FOCIOK or standard work. And in this, what is the aim of improve is with all these tools we are validating the benefits that we are getting from this implementation. And last is control. In this we have already improved, we have already validated the benefits, and then we are implementing that solution, we are maintaining that solution. So control future state process. Okay, then how we can do that with SPC, with visual workplace, with monitoring process. There are different tools for that, and repeat the process. So control, the aim of control is to have this long-term benefits from this implementation, and the benefits received should be sustainable in time. So with this Six Sigma approach, as we have seen, as at start I had said that the 7 quality tools. So these are very essential in problem solving, in process improvement, and also they are called as the old 7, the first 7, or the basic 7, because they are so effective and so powerful that the founder or who emphasized these 7 tools, Kaoru Ishikawa. So what he says about these 7 quality tools, so that is very interesting and inspirational for us. So he says that 95% of the quality related issues can be solved through these 7 fundamental tools. So this is the power of these 7 tools that we can get, and we can solve almost 95% of the quality related issues. What are they? These are the 7: cause and effect diagram, check sheet, control chart, histogram, Pareto chart, scatter diagram, and stratification. So here we will, it is not possible to delve deeply into all these 7. We will just have a look about how these tools are, what is the basic of these tools, and then we will go forward. And to remember these 7 tools, we have created one very easy mnemonic. So we have to go from 3C to S, okay, through HP. You can remember that. We have to go from 3C, cause and effect, check sheet, and control chart, from 3C to 2S, scatter diagram, stratification, and through HP, histogram and Pareto chart. So you can just remember this 3C, 2S, through HP. So this is small mantra you can get to remember all these 7 quality tools. 3C, 2S, through HP. Okay, so now let's see one by one what these tools indicate, what is the power of these tools, and where they can be used. Okay, so the first is cause and effect diagram, and it is also called as the Ishikawa diagram or fishbone diagram. And why it is called fishbone? Because of its shape, and it is similar to the side view of the fish skeleton. So this is kind of, it looks like a fish skeleton, so that's why it is also called as a fishbone diagram. And it is known as Ishikawa because Kaoru Ishikawa, who emphasized this, who invented this practice, and who have implemented it on a wide scale. For that purpose, it is also called as a Ishikawa on his remembrance. It identifies many possible causes for an effect or problem and sorts ideas into useful categories. So generally, whenever we are having the problems, we face multiple problems in industry, right? So let's say there is one problem, and we have to analyze that problem. So what is the root cause of that problem? What are the causing factors that are leading to that outcome? as a problem. So we will categorize it under multiple factors. Generally, there are 6 M's we use: measurements, materials, methods, machine, man, and this is last one is environment. Okay, so whatever the causes, here one example is given of a sheet peel off. So this is our problem, and we are studying what are the causes for that. So in the methods, so which kind of method is we are using, and that is causing that problem. So in this way we can systematically analyze all these causes, and we can reach up to the true cause of that issue. So when to use a fishbone diagram? When identifying possible causes for a problem, especially when a team's thinking is not going toward a root cause. Okay, so we are not getting which is the root cause for the problem. So for that purpose, these are the branches, and there are sub branches as well. So if we found that in the method, so this is a method, temperature during addition. So in that also we can subdivide it, a subdivision we can have, and we can study it until we get to the root cause of that problem. So this is the first of the 7 tools. Second is check sheet. So check sheet is a structured, prepared form for collecting and analyzing data. This is a generic tool that can be adapted for a wide variety of purposes. So what we are doing is, in this we are covering collecting for analyzing data, and we are marking against the let's say some factors are there, so against which we are marking, and this will give us the easiest, and we can analyze that, and through which we can draw the inference as well. So when can we use the check sheet? When data can be observed and collected repeatedly by the same person or at the same location. So either it is a person or either it is the same location. So at that time we can use the check sheet. We can mark against this each of the factor, and that will give us the picture. So what is happening at that process. Also, when collecting data on the frequency or patterns of event, problems, defect or defect location or defect causes, etc. So like in this. So these are the reasons for telephone interruptions and why it is happening. So whenever it happens on Monday, let's say, so we are marking against multiple causes, and that gives us the overall picture of the process. And also collecting data from the production process. So the check sheet. So this is also simple but very effective tool. Third is a control chart. So this is a graph used to study how a process changes over time. So here comes the factor of time. So over the time, how this process is changing. Okay. So these are the observations. The central line, this green line, is a mean. X bar you can see, and there is UCL, that is upper control limit, and this is lower control limit. Okay. So control chart, you can see by the name itself, this is a control limit, upper control limit and lower control limit, and within which we have to keep all our observations, we have to keep all our readings, so that the process doesn't go beyond this control limit. So it also gives a very, very promising tool for comparing current data to the historical control limits, and that leads to the conclusions whether process variation is consistent or not, or it has gone unpredictable, or are there any special effects or special causes that is bringing this observations beyond this control limit. So that we can get easily by observing this control chart. Fourth is a histogram, the most commonly used graph showing frequency distribution and how often each different value in a set of data occurs. So there are multiple times that particular value is occurring in that data set. So we are plotting it against that the whole lot, and we will get that curve like this. We will get such kind of distribution. So this is the frequency. How many times, how many persons, let's say, purchase ticket. what is the response, what is output we are plotting against the response time, and what is the maximum frequency we are getting such. So this is a histogram, and it is a chart that plots the distribution of numeric variable values as a series of bars. And when we analyze that, we can get the feel of the process, how it is changing, how it is, how the frequency, how the variables are changing. Each bar typically covers a range of numeric values, also called as bin or class. A bar's height indicates the frequency, as we have seen. So what is the frequency at that time? How many tickets were sold for that time? The simplest example here is ticket response for the tickets. So you can visualize any tickets for any zoo or sanctuary. So in that you can observe such kind of trend. Okay. Next is Pareto chart. And I must say this is the most effective chart in industry as well as in our personal life. So let's see. A Pareto chart is a type of chart that contains both bars and a line graph, where individual values are represented in descending orders by bars, and cumulative total is represented by the line. So after seeing this, you will get clarity about that. So okay, I think there is some delay. Now you can see Pareto chart, I hope.
Yes, BJ, there's some sort of delay.
Okay. Thank you for letting me know. So I'll stop at the last of that presentation, and then I'll explain, so that you will get the whole view of the presentation.
It has appeared now.
Right. So you are seeing the Pareto chart now, right? So what we are doing in the Pareto chart is we are also using the bars and line graph. Both things we are using in this. And what is the benefit is that we can get easy visualization, which are the most important factors in our process. Okay. So this principle of Pareto chart was suggested by the management thinker Joseph M. Juran, and it was named after the Italian economist Vilfredo Pareto. So from his name, from Pareto's name, this chart is called as a Pareto chart. And it is also called as 80-20 chart, 80-20 rule. So we are familiar with that. So this principle states that for many events, roughly 80% of the effects come from the 20% of the causes. So if we observe this complaint charts, Pareto chart that we have plotted. So if we observe this first three complaints, right? So the first, second, and third, here you can see. So these are cumulative. These three are giving us 88% of the results. Means whatever defects are, whatever complaints we are getting, these are getting from this first three only. So we have to target only this only. So whenever we see in our personal life as well, so this is very important aspect that I think we should dwell on, and that is 20% of our activity will always give us the 80% the maximum benefits, and these are called the value adding activities, and we should focus on these 20% of the activities that gives us the most benefit for our time, the most benefit for our activity. And that is the true meaning time management or project management. So that comes to this Pareto chart. So next, I'll stop at scatter diagram for a few seconds. So the next sixth is a scatter diagram, and it graphs pairs of numerical data. So two variables are there, one variable on each axis, and we are observing the relationship between them in this. Okay, so if the variables are correlated, the points will fall along a line or curve. So we will see some kind of line is there, the points are following that line, points are following that curve, and the better is the correlation, the tighter of the points will hug to the line. Means if we draw a line from these points, so the tighter these points are, there is more correlation between these two variables. For example, we have taken here scatter plot for marks versus study time. So this must be an experience for all of us. Whenever we are increasing the study time for our exam, right, from school days to college days, okay. So whenever the study time increases, the marks are also increases. Okay. Keeping other things as a constant, let's say. So whenever we study more, we get more marks. And if on one subject, in one subject we have not get that much time, then we also get some lesser marks. So such kind of scatter plot, we get the relationship between the two variables, and it is also called as a scatter plot, XY graph, or a correlation chart, as this gives us the correlation between the two variables. The seventh tool, again I'll stop a few seconds. Yeah, so seventh is stratification. So this is the technique that separates data gathered from variety of sources. Okay, in a scatter plot also we have seen. So let's say in the similar way we have plotted some points, and we are not getting any response, we are not getting any correlation between them. So if you can see this diagram, in this we have plotted, we have three reactors, reactor 1, 2 and 3, and we have plotted their output against this input variables, and we have got this graph. So from this graph it is very difficult to draw any conclusion whether there is any pattern or not, or what is the process doing, how it is behaving. So if the data is multiple sources, variety of sources like this, there is data from 3 reactors and that is lumped together, we are analyzing at the same time, and there is we get very difficult to draw any conclusion from that, and for that the stratification is used. So what is the stratification? Let's see in the next diagram. So this is the stratification you can see on the screen. So what we have done, we have separated these readings. We have collected readings separately from reactor 1, reactor 2 and reactor 3 and marked like this. So in this way, on the graph, you will get to know there is some correlation. Okay, the reactor 3, you will get to know there is some correlation, the negative correlation is there. For reactor 2, it is operating on higher values, higher output. So you will get some kind of conclusion by looking at this stratification, and it is also very effective tool to use to get conclusions from this collected data. So as you can see, this data collection and analyze technique separates the data so that pattern can be seen, and we can work on these patterns. Okay, so up to this part, we have seen about Lean, about Six Sigma, about different VEST, 7 quality tools. So with all these tools, there is second part, as we have looked in benefits of Lean Six Sigma approaches. The second part is about there is systematic working or systematic responsibility handling among different people of the industry. So this is the kind of several belt structure or several responsibility structure that we can see. So Six Sigma identifies several key roles for its successful implementation. So we will go from bottom to top, from yellow belt. Mr. Ubaid, can you please mute your microphone? I think it's on. Thank you. Thank you so much. Yeah. So, yeah. So from yellow belt, we will start. so there is hierarchy over here from yellow belt. So who are the yellow belts? So these are the these participate as a project team members, review process improvement, and they are aware of Six Sigma principles. So whenever we see that a person is a yellow belt holder for Six Sigma, so he will be involved as a team member, and he will be aware of all the Six Sigma principles. So the higher level from yellow belt to green belt is a person who is a green belt. He uses these tools in DMAIC approach, as we have seen, DMAIC and Lean, and he will assist in data collection and analysis for black belt projects. And also green belt person will have his individual green belt projects. Okay, then third level is black belt. So this is a person who leads problem solving projects, who trains and coaches project team. And the black belt is a person who is devoting his 100% time in Six Sigma. So he is coaching, he is mentoring to all these peoples under him. And above black belt, there is master black belt. He trains and coaches black belt, green belt, and he also functions at the Six Sigma program level. So if the industry is very big, so there are multiple black belts. So above them, there is one master black belt. So he will coordinate among them, he will train them, he will provide them guidance at the, he will look after the Six Sigma program level. Okay. So if we see the prerequisite for each of these belts, so these are as below. A person who want to get a yellow belt, so it is not having any barrier in terms of education or experience. So anyone who want to get a yellow belt, so he can have this study, and he will appear for certification exam, and he will get this yellow belt. Second is green belt. For the green belt, graduation is required, and 1 year of experience is preferable, because as in a green belt, we are dealing with multiple problems, multiple solutions. So it is better if we are having graduation and 1 year of experience. Then for black belt, the required clause is graduation and 3 years of experience. And also you have to submit one project as a black belt project, and also you have to show the leadership skills, because for black belt you have to manage the green belt, you have to train green belts and yellow belts, and there is a lot of coordinating activities, team management, time management is required. And for that, if a person is going for black belt, he should have a leadership skills. And going further, person who is a black belt, he want to be a master black belt. So the requirement is he should have 5 years of experience as a black belt, or he should have completed 10 Six Sigma black belt projects. So the black belt projects are somewhat big, they are somewhat aspirational, and they are somewhat big. So such kind of 10 SSYB projects he should have completed. And as the master black belt is the top in this ladder of hierarchy, so he should have exceptional leadership skills, because he has to manage, he has to view all these activities of Six Sigma in the institution. So if we see the yellow belt, so the Six Sigma yellow belt certification, why should a person should go for it? Okay, so a person, let's say, who is new to the world of Six Sigma methodology. So if he doesn't know anything about these tools, Lean, Six Sigma, and West, whatever we talked till the time. So all these simple Six Sigma methodology, if he is unaware, he is new for that, then he should go for the yellow belt first. Then who has small role or interest or need, very small need or very small interest for them to develop this knowledge for the Six Sigma, so they can also go for the yellow belt only. Entry level employees and experienced executives, and they only require the overview of Lean Six Sigma methodology. So let's say these are the GMs or VPs or some leadership position person, and he don't want to go into detail of this, which tool you use or in detail hands-on, but he want to just overview of how this approach is used, and he has to overview. So such kind of people as well go for the yellow belt. And as yellow belt is the foundation step of the ladder of this Lean Six Sigma success. So you can start from yellow belt to green, black, and master black belt. So the ladder starts from yellow belt. There is one more belt over there, that is white belt, but that is not as such certification belt, and that's why we have not included in it. It's just introduction to the knowledge of this Lean Six Sigma, the kind of we deal in this webinar. So that is some kind of white belt training. So that's why we have started with this yellow belt. So what this yellow belt will give you? It will improve the intrinsic value, first thing, because in this Six Sigma approach, we improve on ourselves, we improve, we work on this time management, people management. The intrinsic value will also get increased. We become competent. It improves our thinking capability, because when we use such tools, when we work on such methodology, there is invariably we also improve our thinking capability. We also get more promotions, or whenever there is some opportunity for handling the responsibility or handling some leadership activities. So obviously Six Sigma certificate person will get that opportunity first. Then it will also lead to the excellent salary. Then as we have to work as a team, so team management spirit, team management will also increase. Team spirit we will all have if we get such kind of training, and invariably the self-confidence will also increase through this yellow belt. So what this include, as we know that every team member in Lean Six Sigma is important and plays his or her unique role. Therefore, the root of the pyramid should be strong. As we have said that this webinar will deal into the yellow belt in detail. So that's why we are focusing on the yellow belt over here. And why it is important? Because that is the base of the pyramid, root of the pyramid. And that should be strong enough. So the clear concepts and understanding of the issues that will help to solve the problem. Also with the yellow belt, it requires improved understanding of the project definition as well as team roles and responsibilities. So he should have clear understanding of the roles and responsibilities of each person, and that will give with the yellow belt training. Can understand and perform basic functions through DMAIC. So the basic functions of all these tools he should understand as a yellow belt. And the essential thing is go for a training institute which has a practical understanding and certified trainers, because that is very essential to learn this practical understanding. Because if you see the theoretical part, that is not that much essential. What requires for such kind of trainings or such kind of competencies, the practical understanding, the hands-on, the practical exposure, how to draw inference from this tool. So that is really very important, and that's why you should look for the practical understanding of this training. And the examination is for certification. There for yellow belt, it requires the examination to pass the examination of 75 questions. Time is 2 hours, and it's open book examination. And the questions are MCQ type. Computer-based examination is there, and it will cover the basic understanding of DMAIC methodology. So this is the approach. This is the step-by-step procedure to go for the yellow belt certification. So you can register for certification exam, then attend training, practice assignments, then mock examination. As Learn and Apply, we are also providing this mock exam and final examination, and we also provide for that certification as well. So for our trainings, for currently till the time we have completed our green belt and black belts, and we are through this webinar we are officially launching our yellow belt training programs from 3rd of November. But these are some previous reviews, previous feedback about our green and black belt. So I'll not read them out because it's up to you. These are some of the feedback. Only 2 I have mentioned over here. Many more are on our website. So I'll encourage you to visit our website to view what these gentlemen have to say. But I can definitely assure that the quality of training what this training is going to provide. So that is clearing the fundamental doubts and clearing all these concepts and giving hands-on experience. So these are some of the services that we provide. We are having online services and also on-site training as well. And in online courses on our website, there are multiple courses, so they can be accessed anytime and can be completed at your own pace. The second is for Green Belt. We are having online trainings. We have completed 2 batches of our Green Belt already, and our next batch is starting from December. So for Green Belt, SSYB, Green Belt. So that is starting from December. For Yellow Belt, we are starting from 3rd of November, as I have said. And for on-site trainings, we also do provide these kind of trainings, and for that you can contact us on our email address. So we will be happy to help you in any of these Lean Six Sigma methodology. Whatever your issue is, we will definitely provide hand-holding support for it. So these are some of the features of our next training. So that is, we are launching from 3rd of November for its 9 sessions, and each day we will be having 2-hour sessions. So 9 into 2, it is 18-hour session. So from 3, 4, 5, that is Tuesday, Wednesday, and Thursday, and every day at 6 to 8 p.m. So just like the same time. Okay. So 6 to 8 p.m. each day, 2 hours. In this way, 3, 4, 5, 10, 11, 12, and 17, 18, 19. And apart from that, we will be having more than 18 hours of interactive training. We will provide study material, additional Q&A session. Assignments will be there in each week, and additional Q&A session on that assignments will be there. Then in this, free mock exam will be there, certification exam will be there after that. And also one thing that we are offering is the lifelong support for your handholding, because what we are doing is we are making one WhatsApp group, and on that, let's say, similar minded people from all over the industry, all over the globe, when come together. So that kind of support can lift each other. And also one thing that we are offering now is 6 months free access to all these trainings. So whenever we are having next Yellow Belt training, so we will share you all the details. You can, at free of cost, you can have refresh trainings. You can attend second time as well. Okay, so that is no issue. From here, I'll ask for any questions. If you are having any specific questions regarding the topic what we have covered, so I welcome all the questions. You can type on the chat, or you can raise your hand, you can ask.
Yes, BJ, this is Ricky Ventanilla, calling on from the country of the Philippines.
Yeah, please go ahead.
Yeah. My question is there a rule or a guideline as to how many certified number of persons or colleagues in a particular company?
So do you mean how many certified candidates we have created so far?
I mean, yeah. In a particular head count, let's say 1,000 personnel, how many percentage of that would be required to be certified in Yellow Belt or Green Belt?
Okay. So your question is like that in organization or in industries. What is the percentage of people that should be Yellow Belt certified? That's the question?
Yep. Yes.
Okay, that's great. Okay, see, for Yellow Belts in current organization, what is the scenario? The people who, the organizations which are the already Six Sigma organizations. So they are having a very structured way, like they will be having the master black belts, green belts, and they are also having the yellow belts. So they are having their interim structures. But if you see the other organizations which are not a Six Sigma organization, so what is happening in that industry? So that people or candidates have to go outside of the organization to get this kind of training. So we have seen what is the potential of this certification. This is not changing only your professional life, but also impacting your personal life. So it's a way of looking at the life as well as the problem as well as the career is going to be changed drastically. So this is very much important. But if you see what are the requirement in market is like a green belt and black belt is a more requirement. But if you start from the yellow belt, see, because if you are having the background of Six Sigma and if you are directly joining the green belt or black belt, that's fine. But if you are not having the background about the Six Sigma and if you are going directly for the green belts, and then understanding of the concept and understanding of this entire course will be very much difficult. So as Dhananjay has explained in the ladder, so yellow belt is the foundation of all the belts. So if you are not worked in any Six Sigma organization, you don't have so much of knowledge about the Lean and Six Sigma, what are the methodology, how it works, and what are its benefits on both in professional as well as personal life, then yellow belt is the best belt to start with.
Thank you, BJ.
Okay. Yeah. Thank you so much.
Hello, sir. This is Mayur. Hello.
Yeah.
Can you hear me?
Yeah, I can hear. Yes, yes.
Yes, sir. So, like, I am a student from Delhi University, Delhi, and I am like pursuing sustainability management recently. So, I saw the circular economy structure as well in the Learn and Apply website online. So, I would like to know how we would integrate, like, if we would or not in the course structure of Six Sigma.
Okay, so the structure, so whatever the structure we are having, that's Lean Six Sigma, entire, whether it is yellow belt, green belt, or black belt. So we are having a perfect alignment with the ASQ, American Society for the Quality, plus ISSC, that is International Association of Six Sigma Certification, and plus we are having some additional content, so which is very important from the practical perspective. So those some of the content, we are fulfilling 100% criteria for the ASQ as well as ISSC. Plus we are having some extra content that is necessary from the practical execution point of view or practical knowledge point of view. So we are meeting the criteria of both these organizations, which are the best organization in the world.
Okay, no, sir, like I am asking on the circular economy point of view, like you mentioned, circular economy is also important to be incorporated in organizations recently.
Right.
Yeah, so
Right.
how we do
Perfect.
that? Like lean it focuses on cutting the costs and all, right? So how we manage that circular economy and the lean? So does that include in the educational structure of how we would learn that?
Right. If you
Hello.
see Lean Six Sigma, again, these are the methodology. Dhananjay, you want to answer?
No, please go ahead. I'll share my views after you. No issue.
Okay. So if you see Lean and Six Sigma, these are the approaches. So these are we can see there are various tools and techniques are available. And if you see the sustainability, again, this is a very, we can say a very big approach. And if you combine, it's always possible, like if you see Lean is a different approach, Six Sigma is a different approach. But if you merge them, Lean, Six Sigma, and if you go for execution of them, you will get the best results that cannot be achieved alone by the Lean or Six Sigma, right? Similar to that,
Absolutely.
if you combine Lean, Six Sigma as well as the sustainability methodology or sustainability thinking, so we can say the circular economy mainly. So you are not allowing system to produce the waste in the system, right? So instead of reducing the cost, if you are working on totally elimination of the waste or totally modification of the entire ecosystem, then the benefits which cannot be achieved by the Lean Six Sigma, that can be achieved by the sustainability along with combination with Lean and Six Sigma. So, but what's the problem in current practical scenario? Lean and Six Sigma is very much popular in across the globe or across the world, we can say. But sustainability is recently has emerged out, and the awareness in the industries or in the people, or we can say the entire uh, humanity is not of so much or at that level in the current situation. Maybe it will taking some time, let's say 2 years, 3 years, or 5 years, to get that awareness into the people. But we know that it is very much important, and we have starting working on it to merge this Lean Six Sigma as well as sustainability from the starting point.
Okay, sir.
Yeah, and what
Dhananjay?
you can say that this circular economy, let's say, or sustainability. So actually, what is that? So that is only the synergistic approach. Okay, there is synergy, right? And we are always working on that in when we are working in circular economy. But the tools, if you see at the global level as well, there is not as such a foundational tools which can be used for circular economy. And what we are trying to learn and apply this innovative way, so that is, I think, the first of a kind. So we are trying to emerge with this Lean Six Sigma with a circular economy, trying to implement this sustainability. So that is quite of a vast stream, but we are trying to work on that. And we have started recently for the circular economy work.
Okay, so like meanwhile, the structure we can take care of lessons learned from the circular economy as well while learning Lean and Six Sigma.
Right, because if you see this Lean or Six Sigma, what are they? They are only the collection of different tools,
Yeah,
right? Different
absolutely.
different methodologies planned in a systematic way to achieve a specific goal. Okay, so when we are talking about the widening of that goal according to the current times, so that is the need of the time, and that we are trying to do with that. I hope this answers your question.
Yeah, absolutely, sir. Like this is the like basic criteria I want to enter in this Lean and Six Sigma, and I want to like combine these two things
Right,
altogether. Yeah.
right. That is possible. Yeah. Thank you.
Thank you, Mayur. Thank you.
Classes will start from now, please. Hello? The classes will
Yes,
start from now.
yes. It will be starting from November 3rd, right?
3rd. And what is the fees for it, sir?
Fees, I think it is available on the website as well. If you are a student, then it is around 5K. And if you are a professional, then it is around a 7K.
Okay.
Am I right, Dhananjay?
Yes, right. Because what what we have kept it low is because currently we know what is the economic condition for all people. So that's why for student we are offering some direct fees cut, only 5,000 rupees for them, and for professional that is 7,000.
Right.
And still,
And
if you are having issue,
yeah, please go ahead,
so
Dhananjay.
we will also offer some let's say if you want to pay through installments, that is also okay, or if you want part payment, that is also okay, because what we know that the economic problem should not be a barrier in the professional excellence, professional learning, or a pursuit of knowledge. So that that we understand, and that's why if any support required, if you can't pay now, if you are having any issue, we will definitely consider your case as well. You can contact us on this number or on this email address. We will definitely try to help you, because that is our motto for working on this.
Okay. Thank you, sir. Thank you.
Right. Thank you, Sanjay.
Good evening, Ubaid here. Yeah, I have one question, right? I just want to clear if someone means come with the 10 or 20 numbers, right? So any concession in fees as a organization?
Yes. Of course. There will be we can say if you're talking like a 20 students, there will be the huge concession will be there.
No. I just want to means share from the organization. If I connect with you, as means I am just sending 10 our employees, right? for attending this training, right? As a professional, right? A black belt or yellow belt or green belt. So as a group, right? You will give some discount.
100%. We will give discount.
Yeah. So I will connect separately, right? So we just want to align, right? Okay. Thank you.
Sure.
Thank
Dr. Ben. Yeah, right. Thank you.
If you are having any question regarding concept also, you can ask, because it's not like that you have to ask only about course. If you have any question regarding the concept we covered or anything, you can ask. No issue. We will cover that.
Okay, I think there are no questions. Okay, so if no questions at this time, it's okay. But afterwards, if you are also having some questions, so you can see there are the numbers on the screen. So there are the numbers. These numbers also available on the WhatsApp as well. So you can put the message on WhatsApp as well as you can put the text message. This is the email address on which you can keep us in contact, so that if you are having any query or any questions, we can contact us. Thank you so much. Yogesh, do you want to add anything?
No, nothing from my side. Everything is good.
Okay.
Yeah, thank you.
Okay,
Thank you both.
If no questions, then we can stop. Okay, thank you so much. Thank you so much for your questions, your valuable
Thank you,
time,
Vijay.
and have a great time. Yeah, thank you.
You too. Thanks.
Take care.
Thank you, sir. Bye-bye.
Yeah, thank you.